We're going to start with some review on congruent and similar figures. And first we're going to start with congruent figures. So congruent figures have the same shape and size. Everything in them is identical. With congruent figures, we have a congruent statement, which is this entire piece right here. This right here is called my congruent statement. And it is very valuable information. It tells me all the corresponding angles and all the corresponding sides in those polygons, which are exactly identical since they're congruent figures. The symbol in the middle is my symbol for congruent. It is an equal sign with a little wave above it. So the directions in this question say that we're going to highlight all corresponding sides. So basically we're finding all those sides in those two polygons that are exactly identical. And this congruent statement allows me to do that. So I'm going to find all the letters that represent the sides that are in the same spot in my congruent statement, and that tells me who is corresponding and congruent in the two figures. So since letters C, D, and R, S are in the same spot in that congruent statement, they're both the first and second letters, that means that they are corresponding in those two polygons. So I'm going to highlight those two. So I have side C, D, and also side R, S. So remember, you can't just go by how it looks and say that, oh, that side is on the top and so is this one, so they're corresponding. That's not always necessarily true because sometimes these figures get turned or flipped and moved around. D, E, and S, T are both the second and third letters in that congruent statement, so they are also corresponding. So I have side D, E, and side S, T are corresponding and congruent as well. Side E, A, and side TP are both the third and fourth letters, so they are also corresponding and congruent. Side AB and PQ are both the last two letters in that congruent statement, so they are corresponding and congruent, meaning that they're going to be the same length in measurement. And now lastly, I have just one side left, but I do want to make sure, so let's make sure that it matches up with my congruent statement. So side CB are the first and last letters, and so are RQ. So they are corresponding and congruent, the same measurements. Now we're going to go the other way around. So it says write the congruent statement for the set of quadrilaterals. What's nice about this example is that each one of those angle measurements are given to us. So we can use those angle measurements to help us write this congruent statement. So I'm going to go through and I'm going to mark all my congruent angles. So right here I see an angle of 49 degrees. So I'm going to find my other angle of 49 degrees, which would be angle S. So I'm going to give him the same type of marking to show that, hey, those two angles are congruent. I see an angle measurement of 104. So I'm going to find the other angle measurement of 104 and give them a symbol to show that they are the same. And then I see an angle measurement of 127. So I'm going to give him 3 loops there in the same spot. And then I'm just going to leave my 80 degrees unmarked. I will understand that they are the same measurement. So when I'm writing this congruent statement, I can choose to name my first polygon any way I want, but then the second polygon needs to follow in the same order to show all those corresponding parts. So I'm going to name this first quadrilateral HIJG. Then I'm going to use my congruent statement, which is the equal sign with the wave above it. Then I need to find who is corresponding and congruent to angle H, which is angle S, because they're both 49 degrees. And then I'm going to follow that for I, J, and G. So that would be my congruent statement for those two polygons. Here we have two congruent triangles, two pairs of congruent triangles, and we can prove that they're congruent. And remember, we have those shortcuts to prove that they are congruent. One of those shortcuts is side, angle, side. So since I see a pair of sides, I see an angle, and then I see another pair of sides and another pair of sides. I don't even have to know that the rest of those pieces in that triangle are congruent because side, angle, side is already enough information. So when I specifically have triangles, I can use shortcuts to prove that they are congruent. Another shortcut I can use is angle, side, angle. So I have an angle and another angle. I have a pair of sides and a pair of sides, and then I see this other pair of congruent angles. So notice how the side is in between the two angles that are shown that are congruent. Just like over here, the angle was in between the two sides that were congruent. Other forms of shortcuts that I can use to prove triangles are congruent would be side, side, side. So I see 3 pairs of congruent sides. Or angle, angle, side, where the angle given and the side is on the outside of that 2 pairs of congruent angles. Remember, side, side, angle does not prove congruent triangles. Lastly, we're going to use a similarity statement and a picture of 2 quadrilaterals that are similar to find some missing sides and a missing angle. So remember, similar figures have the same shape, but not necessarily the same size. Their sides are proportional, to be exact. So they're not congruent, they're proportional, meaning that they grow or get smaller at the same rate. Now, even though this question is not asking me to find all corresponding sides, I'm going to go ahead and highlight all of them because I think it is very helpful for me when I'm setting up my proportions or my growth factors to find missing sides. So as I use that similarity statement right up here, I'm going to highlight all my corresponding sides. So side MN is in the same spot of RS. Side NP is in the same spot as ST. Side PQ is in the same spot as TU. And then lastly, also just double checking, RU is the first and last, and so is MQ. So that's going to be helpful for me when I find these missing sides. So I'm asked to find the length of side X, the length of side Y, and then this last little piece right here is asking me to find the measurement of angle Z. Well, I don't even have to do any math to find that. So since these are similar, that means that they keep the same shape. In order to keep the same shape, all corresponding angles are congruent. They're the same measurements. I know that angle M, which is where Z is at, is in the same spot as angle R. They're corresponding, they're congruent, they're the same measurements. And I see over here next to angle R a measurement of 115 degrees. So that means that angle M is also 115 degrees because they're corresponding in those similar figures. Then to find side X. One way to find side X is to use a proportion. Since their sides are proportional, we can set up our proportion to find that missing side. So to set up our proportion where we have a ratio set equal to another ratio, we need to have one ratio where we know the measurements of both. So we start with a pair of corresponding sides. One pair of corresponding sides where I know the measurements of both are the 18 and 30. So as I write that ratio, I'm doing the little quadrilateral over the big quadrilateral. So when I set up my other ratio in that proportion, I need to make sure I follow the same order. Side X is coming from the little quadrilateral, so I'm going to put it on top of that second ratio. Corresponding to side X is side ST, which is a measurement of 25. Then to solve proportions, I use cross products. So I know that in proportions, my cross products are equal to each other. So I'm going to set those 2 cross products equal to each other. The product of 18 and 25 set equal to the product of 30 and X. So I'm going to multiply 18 times 25 to get 450. And then my last step to solve this simple equation is to use inverse operations. So I'm going to divide both sides by 30, because 30 over 30 is 1. 1 times X is X. And 450 divided by 30 is 15. So the length of side X is a measurement of 15. One other way to find a missing side in similar figures is to find the growth rate. So I could also find the growth rate of these 2 quadrilaterals. The growth rate when I divide these 2 is 0.6. So that means that the smaller quadrilateral is exactly 0.6 the size of the bigger quadrilateral. I know that 15 is coming from the little quadrilateral. So I need to get bigger, so I'm going to divide by that growth factor, and that's going to give me this measurement of side Y, which would be 25. You could also set up your proportions once again and use cross products to solve. So little over big, 15 is coming from the bigger quadrilateral, so it would go on the bottom, and you'd find that side y by using cross products. So that's also another way to find that missing side.